Good afternoon to you all. We are going to continue this topic, and I think last time we finished calculating for the local similarities, and we spent a lot of time calculating it. If you remembered, we started calculating everything from the dam, the local similarity from the dam water level. So we compared this into this, and also we did a comparison for the level of water in the river Fahang, which is 12. We compared it with this one with the days here, so day 5. And also we did a comparison for the local similarity of soy, which is this. We tried to make comparisons on each value here on each day. And also last time we did the comparison for pecan. Okay, same the pecan here for the day 5 and pecan of day 1, day 2, day 3, and day 4. Likewise, we finally finished the local similarity comparison of day 5 for Gambang, the water level of river Gambang and the water level of Gambang in day 1, day 2, day 3, and day 4. Now, we need to go to the next step, which is global similarity. As we discussed last time, if you remember in the theoretical part, the global similarity is the totality of the comparison. Okay, so it's the build-up. So after doing the comparison for each attribute, we're now going to compare it as a whole. This time we're not focusing on individual attributes or properties, but we are now concerned with the totality, this global. So it means that if you just to give a summary of what we have discussed last time, when we go with the local similarity, okay, LS, we are focusing on the column, okay, columns, okay. Comparison is made on the columns, okay. So this is our local similarity. Now for the global similarity, our comparison for the global similarity, our concern now is comparison is made on the rows, okay? Rows now, not the columns, but this time we're going to make comparison on the rows. Okay, so you have noticed last time when we did the comparison for local similarity, we only focus on each column. Dam water level of day 5 versus the columns here, and then Pahang 12 versus the columns here. But this time, when you go with the global similarity, we will be focusing on the rows, meaning here. Okay, this row here, what is the similarity with this one here? So this is now our focus on the global similarity, which is on the rows, as I mentioned earlier. So our focus now will be here on the rows here. Okay, so that will be our focus. So let's proceed with the global similarity. The global similarity is taking the formula as shown in the PowerPoint. So the global similarity of A, the new, this one, and the old one is equal to 1 over the summation of the weights. So meaning we will be now considering here the weights. Okay, so when you say weights, there is some columns in our problem which is having more importance than the rest of the column. Let's say for example here on our case, according to our case here, let me just go back with the previous sample here. River Pahang and River Pecan are more important than the other rivers here. Meaning, we give much weight to Pahang and Pecan. Okay, so please make note of that. So Pecan and Pahang, they are very important. So meaning, the water level is not that much important when it comes to the weights, okay? Weights of the attribute. When you say weight, it's quite similar to when you go with the applicants, right? Let's say, for example, if you are looking for the applicants, in the example that we had last time, normally we look for the experience, right? So experience is more important than the other attributes, correct? So let's say, for example, if we are comparing between experience and gender, okay, which is more valuable, the gender or the experience? Of course, depending on the job description, but mostly we are looking at the experience and as the major factor when we hire somebody, correct? Let's say, for example, which is more important, the age or the GPA? So you have to look at this. So this is the issue that we have to look at when we talk with the weights. So in this example, Pahang and Pecan, they have very high weights when it comes to the rest of the river, meaning the dam water level is 1. So the weight of this is 1. Pahang is 2 as per the case study, and then Pecan is also 2. So it means that when we go with the comparison, we have to look on the weights. Okay? We have to look on the weights here. This is very important, the weights. And also, the formula, we have to multiply 1 over weight multiplied by the summation. We're going to add all the similarities multiplied by the weight of each attribute of A and B. The similarities we computed earlier. Okay? So it means that we have to make a summary of our, what call this one? We have to make a summary of our similarity measures into one table for us to be able to calculate the global similarity. So for the meantime, let me just copy this and paste it in our whiteboard so that we could have a reference of this. So the formula for the global similarity is this. Let me just copy it for the meantime. And let me paste it in our whiteboard. Okay, so let me just put it for the global similarity, pastes. Okay. For the global similarity, we have to follow this formula. Okay. It says in here 1 over the summation of the weights. Okay. So we have to calculate the summation of the weight. So let's try to calculate first summation of the weights. Okay, just call it weights. Okay, 1 divided by the summation of the weights. Okay. So let's go with the summation of the weights here. Let me just delete this. I think no need for this one. Let me just take here in the PowerPoint, new, and then let me go with this. I need to calculate this. Okay, let me get this image and paste it here in the whiteboard. Okay, let me just get it in here. So let's try to write down again dam water level. Okay, let me write in here weights. Okay, dam water level What's the weight? 1, right? Then next one, Pahang. Pahang is how much according to the problem? 2, right? So the other one, where it is? Oh, sorry, Control Z. In this example, pekan is 2. Pahang and pekan is 2. So the next river is soy. Soy will be taking only 1. Then pekan is 2, right? As per the problem given here. And then we have gambang. Gambang is taking as 1. Okay. So these are the things we have to look at. Okay. So let's now try to calculate this. So let's take the weights first. Let me just put the weights here. So we just have to do this one. So just have to write equals 1 divided by 1 plus 2 plus 1 plus 2 plus 1. Okay? So this is it. Equals, anybody can tell me how much is this? Let me go with my calculator. Let me go with the whiteboard. So this is 1 divided by close parenthesis 1 plus 2 plus 1 plus 2 plus 1 close parenthesis equals 1 out of 7, which is 0.143. By the way, during examination, I only require you to round off all your values into 3 decimal points. Okay, like this: 0.143, 3 decimal place. So let me just. My calculator says it's 0.1428. So round off meaning 0.143. Okay, this is this rounding off 0.143, because the next. So we are now ready for the first part of the formula. We're finished with this. Okay, then we're going to multiply it by the summation of the weights and the similarity of A and B. So before we proceed to that, let me do first the table, the one I told you earlier. We have to make a table for the previous computation. Okay, so the computation we made here, this one and this one, we just have to summarize them into single table. Okay, we're going to summarize them using the single table. So let me just make a table for you. So this is so how many? 1, 2, 3, 4, 5, 6. 6 columns and 6 rows. Okay, so 6 columns and 6 rows. So the first one is the first one is day, right? Yeah. So this is day 1. This is day 2. This is day 3. This is day 3, right? Then day 4. We need day 4. 4. So I just have to delete this later, no problem. Okay, then after this, let's go with the Pahang. The first one is Pahang, right? So let me just write it here in the top. The first one for Pahang is 0.685. We're just doing the summary, okay? And the other one is 0.634. Then we have 0.701. And the last one is 0.365. So these are the values we calculated last time. And the next river is soy. So the calculated values for the LS, the one we solved last time, 0.105. And then the other value is 0.043. And then the other value is 0.895. Then we have 0.162. Let me place it in here. Okay. Then for the river Pecan, we have it in here. Okay, so the first value for Pecan is 0.449 for the first day, the similarity. Then we have 0.550 for the second day. Then we have 1.000 for the third day. And we have negative 0.001 for this, for the fourth day. And lastly, the last river, which is Gambang. Gambang is here. So we have Pahang, soy, Pecan, Gambang. Oh, I forget the day, right? The level, the water level for the dam. I forgot it. No problem. We can move it later on. Okay, this is it. Okay. So let's now calculate for the global similarity. Let me just put an extra row here, which is, let me call it global similarity. Okay. So we have to calculate it using the formula here. Remember the formula. It says 1 over summation of the weights, which is we calculated earlier, which is 0.143. So we could write something here for day 1, 0.143. This. Okay. Next, we have to go with the next portion, which is, it says multiplied by. Let me just write something here like a star. Multiplied by, the next formula is the summation of the weights times the similarity, okay, of A and B. So this, and this. We have to add it, but this time we have to consider the weights, okay. Pahang and Pecan, they take 2, so we have to write 2 on that one. Let me just highlight it so that you will see that Pecan is having importance, Pahang and also Pecan. Okay, so 1, 1, 2. So we just have to do the multiplication in weight times the similarity. Okay. So in this case, I have to do multiplied by close parenthesis. So this one will become 1 times 0.904. Okay, Why it is like this? Why we have 1? Because the dam only have the weight of 1. Okay? So let me close it like this so that you will know what I'm doing. Plus, Pahang is 2, right? 2 times, let me just close it in parentheses so that you will know I'm working with Pahang. 2 times 0.685 plus soy is 1, so we have to go with 1 times negative this negative number, so we have to close it in the parentheses, negative 0.105 plus pecan is 2 again because it's having 2 values, 2 times 0.449, right? So let me just elongate it so that you will see. Then not yet finished, we still have gambang. Gambang is 1 plus 1 times 0.206 for gambang. So eventually we will get how much here? Equals, go with your calculator and then you can see 0.143 times close parenthesis, get inside, then close parenthesis, get inside, 1 times 0.904, and then you have to go with the next one, plus close parenthesis, get inside, which is 2 times 0.685, then plus close parenthesis, get inside, 1 times negative 0.105, go outside, plus close parenthesis, get inside, 2 times 0.449, go outside, plus lastly we have close parenthesis, get inside, 1 times 0.206. So if you're done with it, press the enter key, then you will see 0.468. so this is 0.468. Okay, so this is the global similarity now. The totality of the similarity is 0.468. Converting this to 100, this is equivalent to 46.8%. Meaning day one is 46.8 similarity with our problem, which is in the given, right? So meaning day 5, which is in here, sorry, let me write day 5. Let me just write in here for day 5. So what was the given for day 5, if you remember? Would you please tell me? What were the given for day 5? Day 5, we have 29.50, we have 12, we have 20, we have 22, we have 20. Okay. So let me just say something right in here so that we just know what we are comparing. 29.5, this is 0. Then we have the other one, pastes, which is 12.00. Let me just write in here, pastes 20 point. Okay, then we have pastes 22.123. This is the given, right? Then we have plus, we have 20. Okay, so let me just add one additional row here. How could I add a new row here? Okay, I cannot add a new row. We just have to move this somewhere here. Day 1 is what? Open or close? It's open or close? I don't know. Let me just write in here decision. Let me just write it for you. Open, close, close, open. Okay. Open, close, close, and paste open. So our question is this one. We don't know yet, right? Unless we see the comparison later. Okay. So based on our computation, day 1 is 46.8% similar with day 5. So let's try to calculate 2, 3, and 4. Okay? And then later we will see which solution for the gate we're going to adopt for day 5. Are we going to open or close the gate in day 5? So as of the moment, we have 46.8% similarity for day 1. Okay, I made a summary for you. You can now join it. I did a summary for you, so you can now put the values here. You just have to calculate it. So what's the value?
So
Tell me.
0.8859 or 85.9%.
Very good. 0.859 or 85.9%. Very good.
Yes.
How about the second one? Abir left. I think Abir left the conference. Mahara, did you finish the last day there? Day 4. Mahara. Najla, can you please do the second day, please? And Ibrahim, can you please do the last day? Because I think these people disconnected. For day 2, please do it to Najla, and for day 4, Ibrahim, please do it. So as of the moment, we have noticed that day 3, which was calculated by Basma, we have noticed that day 3 has 85.9% similarity with day 5. So let's see which among this will be applied for day 5. Is it day 2, I mean day 3 with close, or are we going to... So we will find out later. So for now, we have day 3 as the highest similarity, so we might select it. If in case day 2 will be having higher value than day 3, or day 4 will be having higher value, then we will select from them. So we cannot decide yet until all of these are finished. So Najla, tell me dear when you're ready, okay? For day 2. So you have to take note. Let me write a note again here. Global similarity is the basis for decision.
Yes, doctor. 0.2408.
The last day, right? 0.
Yes.
0.240.
40.
This is sure? Which is 24%, right? 24%. Is this correct? 24%? Okay, Najla?
Okay, Mr.
Finished?
Yes.
What is the value there? Tell me.
0.563.
53. 0.5.
Yes. 5.
3.
6.
5, 6.
3.
563. Okay. So this also equivalent to
56. Yeah.
0.3%. I'm assuming, okay, that your answers are correct, okay? I'm only assuming that your answers are correct. I want to validate them. I'm assuming your calculations are correct. So based on our example here, we have 85.9% as the highest, to be followed by day 2, day 1, and lastly we have day 4. So in this case, since day 3 has the highest percentage, so meaning we could decide if you're satisfied, okay, let me just tell you this, depending on your set point, okay, depending on your set point, let's say for example your set point is, example, okay, choosing solution depends on your set point, okay? Depends on the set point. Let's say for example, if your set point is 90%, example, if set point is 90% similarity, okay, example only. Let's say for example the set point is 90% similarity. Can we choose from the existing solution? Can we choose from the existing solution if the set point is 90%? Let's say for example they say we will only choose the decision or the solution that is 90% similar. So what will be our decision here? Then what will happen? No solution is selected, right? So this will be the problem if the set point is 90% similarity. So depending on how the system was designed, you have to look for the set point. In this example, we are not setting the set point since there is no set point stated in the problem given to you. So we will select this as our basis for the solution. It means that we're going to select this one. Therefore, the decision to be made for day 5 would be what? It should be closed based on the similarity of 89%. Okay? So in this example, we have a solution which is quite similar or quite the same as our new problem, which is day 3. So we're going to choose day 3, okay? In this one, let me just put a note. Let's put a note on this. Okay, choose day 3 for the reason it has a very high similarity. So in that way, you can now go with the next phase of case-based reasoning, which is reuse. So when we say reuse, no modification, okay, of the solution, just copy it, okay? Just copy it, meaning you just have to adapt. Based on this example, we can just simply adopt this solution. Simply, what we will do is we will write close here. We will adopt the solution which is close, and we will put it here. So that's the adopt, okay? We're going to adopt it. So, or if you want, you can do the manual or interactive solution, or you can make some programs to make an automatic solution adaptation. Like what I'm saying earlier, let's say for example, we will adopt the solution if the set point is met. Let's say for example 90%. So if it's not 90%, and then we could go with the next phase, which is the next phase is actually revise. Clear? So revising means if we don't have solution quite similar to the new problem, then we have to revise. We have to create our own solution. So sometimes what we look at the revision stage of the CBR is this one, correctness of the solution. So if you will see on our example, the similarity of the problem is only 85.9%, right? So we are not sure if this solution here will be really applicable to the case. So let's say for example, as I mentioned earlier, let's say I want 90% similarity, okay? I want 90% similarity, but the problem is the current database only provided to me this 85.9 similarity. In this way, 90 was not met. In this case, I have to go with the next phase, which is revise phase. We have to go with the revision. We have to change the solution, modify it, and adapt it. So let me just create a flow chart so that you will know when to go with the next phase, right? So basically the flow chart is very simple. You can analyze it. So we have a new problem, right? So basically when you go with a new problem, the next step is we have to go with retrieve, right? So this retrieve is the next phase of the algorithm. Oh, sorry, Control Z. Let me just make sorry, Control Z. Let me just clear a thicker one. So we have the new problem. So we have to retrieve it, right? So in the retrieval process, you will be conducting the two steps, right? Let me just summarize to you what we have done earlier. So Control Z. So in this one, we did two things, right? So the first one is we go with local similarity. And then we go with the other one, which is global similarity, right? Okay. Control Z. So this is what we do. Correct. So this is the retrieve. So what you will do here is we will do some if statement. Correct. So we have another one here. Let me just draw one object. So I'm writing here. Is the set point set? So you have to ask this question, right? Sorry for this, Control Z. So you have to ask this question. Is the set point set? Okay, is the set point set? If the answer is no, what do we do? If the answer is no, what do we do? Then you have to go with the next level. This is the basic flow chart. So you have to ask this question, okay? So you have to ask this question, is there a case having the highest similarity? So you have to go with this flow chart here. Okay, is there a case having the highest similarity? If your answer is yes, if the answer is yes, then go with the next step, which is which one? Reuse. You go with reuse, okay? Meaning you're just going to adapt. We're going to reuse it. If no, what we will do? The next solution will be, if there is no highest similarity case, then what we will do? Then we have to revise it, right? Then you have to go with revise. So this is the probable solution we will go. If there is no, okay, so you have to write in here no. So this is your flow chart on how to do the decision process. Okay, now let's go back on the side of the set point. Is there a set point? If the answer is yes, then go with the next level. If the answer is yes, go with the next level. So it says in here yes. Okay, and go with the next level. So go with the next level, then you have to make note of this. So ask this question again. Was the set point met? Okay, so you have to answer this question, the set point. If your answer is yes, okay, let me just go up, and let me go down here, make it very long. Okay, so if the answer is yes, then go with reuse. Okay, so this is how you will do it. If the answer is no, meaning the set point was not met, and then you have to go with revise. Okay, so this is the total, your flow chart for your case-based reasoning for all the cycles. Okay, so let me just repeat it. You have a new problem, you have to retrieve from our knowledge base, then you have to calculate local similarity, the one we have done earlier, then compute for the global similarity. Of course, results will be given to you. Then you have to ask question, is set point set? Meaning, do we have any criteria for selection? Let's say, for example, in this case, we say 90%. So, if the answer is no, then you have to go straight. Ask yourselves, is there a case having the highest similarity? In this example we have, which is 85%. And then we have to go with reuse. We just simply apply the solution here, which we said earlier we will get close. Apply close here because this one is sorry. We were going to apply close because day 3 is similar to the new problem. So this one. Okay, so we just simply adapt it. If there is no solution, then you have to revise. Okay, you have to revise. Okay, so you have to revise the solution. You have to create your own solution for that. Okay, then after this, go with the retain. The last stage of the CBR is retain, meaning you have to retain. The new problem and its solution should be retained in the database. So let me just write in here. Retain means put the new problem and the solution to the database, to the knowledge base. Okay, so we will add it as part of the experience. Now, if there is a set point set, you have to look at this. If there's a set point, then you have to ask, was the set point met? If the answer is yes, go reuse it. If the answer is no, then you have to revise it. Okay, basically this is the flow chart that you're going to do for the CBR. So then, after doing the revision, you can go with the reuse or revise. It's all up to you. And then you have to go with the retain. Okay, So retain means we have to add the new case or the new experience in our database. Okay? So that next time if you're going to encounter the same problem, our case-based reasoning database is ready to provide a similar solution because this new problem that we had is retained in the database. So the more problems and the more solutions we have in the database, the more intelligent would be our CBR. So we have to store it in our database. So in this case, we are done with the theoretical parts and sample calculations for the CBR. Okay. So next meeting, I'll be giving you another exercise, which is we will do on Monday and Tuesday. God willing, we'll be doing another exercise. This time, I'll be giving you combination of both. Okay, for the case-based reasoning, I'll be giving you a combination of both. So which is CBR practice, this one. Okay, we'll try to solve this next meeting. So this is an example. Okay, so we have the case 1, 2, 3, 4, 5, 6, and then we have a new case which is case 7. So the blood pressure is 75, the albumin is 1, the sugar is 1, and then the red blood cells is normal, and then anemia is no. So we want to know here, we want to see if the patient is having chronic kidney disease. Okay, so it's just simply a medical case wherein you want to know if the person is having chronic kidney disease or not. So this is the example of this. So for patient 1 or for the case, actually these cases are also equivalent to patient. Okay, patient before, the patient before is patient 1 in the old example, control Z, is having these symptoms or this health reading. Patient 1 has blood pressure of 90, albumin is 1, sugar level is 0, red blood cells is normal, and then anemia, yes. So it says it's having chronic disease, kidney disease. Okay, so from here we're going to predict what do you think is the health condition of this patient here, patient X. Is he having kidney problem or not based on this exercises, this given parameters here. So inshallah or God willing, next meeting we will do this.